Okay, so welcome everybody, and I'm going to introduce Nick Owens, our speaker this evening. Nick is a director of HKD Energy, Ovesco, and another community benefit society that put solar panels on schools and run solar farms for the public good. In 2019-20, he did an MSc in architecture and the sustainable environment at the University of Kent. And he and his wife, Sally, have put that learning into practice by a top to bottom deep retrofit of their house in Hassocks, which isn't too far from where we are in Linfield here. In this talk, he's going to explain how it's being done and give us a few tips on this and other messages and other measures that can also be taken to save energy and costs. So what he'll do is he'll talk for 20 minutes, do a presentation for 20 minutes, have Q&A for 10 minutes so that we have a bit of a break. Then he'll talk for another 20 minutes with Q&A. And that would be the end of our recording and our session. So over to you, Nick.
Thank you very much, Chris. And hello, everybody. And I'm very glad to be here with you this evening. Let me share my screen and you'll see what I'm going to be talking about and what we've been struggling with, well, enjoying over the last few months. And I'm sorry, I'm at the wrong place in the presentation, so I'll go all the way to the beginning. Here we are. Okay, so I'm going to illustrate the things you can do in saving energy in a house retrofit by talking about the one that we've been doing. It's still in progress, actually. So the scaffolding is still outside the house. And there you can see Sally looking in wonder at this horrible monstrosity that I've imposed upon her. So that's the back of the house.
Nick, you haven't shared your screen yet.
Oh, right. Let me try again. Let me try again. I'm glad we've got some technical skills to be on track. Okay, can everybody see that screen?
Yeah. Yes, we can.
Okay, so
yeah, over there.
I'll be talking about the retrofit of this house that we live in. There's my wife Sally looking in wonder at the horror that I've imposed upon us. That's the back of the house. It's sited about 10 kilometers from the sea in Hassocks. So the prevailing wind and smog and whatever, to the extent that there is smog, comes from Shoreham by Sea. We're located on a B road, so there's a lot of traffic at the front of the house, and there's an A road with even heavier traffic going north-south, very close. So in fact, the crossroads where those red lines intersect is the only air quality management area in Hassocks, i.e. it's the place with the worst air pollution, sorry, in the whole of Sussex. Not that the air seems bad because it's blowing from west to east, but it's relative. So this is what the house looked like before we started. So that's the front, a chalet bungalow, some fairly worn tiles on the front, a few solar panels, but getting in need of work being done on it, and quite a lot of those windows are rotten, so they need sorting out. That's the back without the scaffolding before we started. What we were trying to do was reduce the overall energy consumption and heat demand. So the house previously consumed about 23,500 kilowatt hours of energy a year, which to me seems quite a lot. So that's bills of 1,250 a year. And we're aiming to get that down by 87%, which is a pretty big step, down to about 3,000 kilowatt hours a year. The overall bills probably won't go down because we're switching from gas to electricity, and the price ratio of those things is 1 to 5. So the more electricity you use in place of gas, the more your bill goes up. However, it's saving the climate because there's far less carbon emissions. So hey ho, that's what it's about. So I'm going to talk about whole house retrofits. This wasn't our house, by the way. This was just a rather charming barn nearby that's crying out for someone to give it love and attention. So I thought you'd like the picture. Why do people do retrofits? One of the first reasons, of course, is to have falling energy usage and potentially a lower cost. You can see from the blue and orange bars, those were our gas and electricity bills running through till August, when the gas was disconnected. The heat pump that we've used went in March, and the projection is somewhat lower than last year. So we will have considerably lower bills, I think, from where we're going forward in this retrofit. Increased comfort is another huge reason for doing retrofits. The pre-retrofit house both over and underheated and was often very drafty. You can see from the graph that in the heat wave in June 2020, some of the rooms got up to over 30 degrees. So we're well outside any sort of comfort zone. But a few days later, when the weather turned colder, the whole house was too cold and again outside a comfort zone. So it was in need of attention. As a comparator, this is a similar graph from a highly energy efficient house near Maidstone in a place called Bockton Ridge. And this is a passive house, i.e. one that's been built to a very high energy efficiency standard. And you can see that the temperatures in the rooms vary hardly at all by maybe 1 or 2 degrees throughout the day and night. So you can achieve very stable temperatures and very comfortable rooms with 0 drafts by undertaking energy efficiency retrofits. Another reason for doing a retrofit can be to improve the quality of the ventilation. Some houses nowadays have a ventilation system that warms the colder but fresher air that's coming in with the warmth of stale air going out. And the result is a building that never feels stuffy or has old cooking or other smells. And the occupants can more easily stay alert and concentrate on whatever they're trying to do. So this type of ventilation system is called mechanical ventilation with heat recovery, MVHR, and I'll be talking more about that later on. Last but not least, the goal, of course, is to reduce your carbon footprint. And this shows what ours was. Well, this is for a single person, so this was mine before the retrofit and after the retrofit. These footprints come from the Worldwide Fund for Nature's website, which lets you calculate these. And you can see that the impact of doing the retrofit is fairly considerable. So the structure of this talk then, and covering what we're doing at 8 Hurst Road, some of the initial steps in the energy efficiency retrofit. We've put in an air source heat pump, we've got the ventilation system, and we've insulated the pitched roof, both inside the rafters and outside the rafters. We'll then have the Q&A, and I'll then talk more about 3 further retrofit measures and cover some practical tips on how to reduce your energy bills. So that's the agenda for today. Let's look at the heat pump first of all. We've put in a Samsung heat pump that replaced a condensing gas boiler. And this is an 8 kilowatt one, but actually, even if it was a 16 kilowatt one, the box would be exactly the same size. So that's about 1 meter square and 30 centimeters deep. When you put in a heat pump, you also need to make sure your hot water tank's very efficient. So there's a new hot water tank in the loft. You might be interested to know that the efficiency of a heat pump depends on the weather. So the dots are various readings I took over a few weeks during April. And you can see that the average line that they depict is sloping slightly upwards. So as the temperature increases, your heat pump actually gets more efficient. A lot of suppliers will tell you that they can achieve an efficiency of something like 3.8 or even 4. So that's 4 times more energy coming out than you have to put in to power the pump. That all depends on whether you're running just the heating, which is what they're talking about, or the heating and the hot water, which gives you a lower result. I'll come on to that more later on. What size heat pump you need depends on how much insulation you've got. So these two graphs are on the same scale vertically. It might not look like it, but they are. So the top graph is the amount of gas that we were using, the grey bars, before the heat pump went in. And we had a peak demand in winter and in December and January of about 22 kilowatts. So that's a heck of a lot of heat being emitted at any point in time. The graph at the bottom is the result that we expect to have once all our works are completed. So you can see that the heat demand is hugely less. And there's a little calculation to identify whether 8 kilowatts is big enough for both heat and hot water. What it's looking like is, even if you have a bath every 2 hours, you'd be able to heat the water tank from cold in 2 hours. And so, yes, it would indeed be sufficient. In fact, in a very energy efficient house, it's hard to get a heat pump that's small enough and runs efficiently. A question I often get asked is, how do you get the Renewable Heat Incentive grant, the RHI grant, in order to pay for your heat pump? And although our heat pump cost just under £10,000, we're actually going to get more than £10,000 back as a grant. So the way this works is as follows. You have to start off by before you do any work, having an up-to-date energy performance certificate. That's one that's less than 2 years old. So the worse the house is, the better starting point it is from getting a grant. The next step is to get an accredited installer to quote for the work and get them to install and do it. And you have to pay the cash up front for that. The installer will then set up and commission your system and give you a claim code, which you can then take to Ofgem and input those details on their website, which then triggers the payment of a grant over 7 years. So you get the money back in 28 chunks. Now, it may seem a lot of money up front, but this is the only grant available, and this is how it works. So I would assure you, it's worth doing if you can do it. Even if you have to borrow the money, it may well be worth doing. Let's look now at roof insulation. There are 3 possible methods of doing this. There's the cold roof approach to insulate just the ceiling in the loft. Then a warm roof approach where you insulate between the rafters in the loft, and another warm roof approach where you insulate both between and above the rafters. So I'll cover all of these three. So the cold roof approach, first of all, the objective is, I would suggest, to get your loft insulation to a depth of 300 or 400 millimeters, because that will give you really considerable energy savings. Loft insulation is the lowest cost method of saving energy that there is. You don't have to use rock wool, that nasty glassy fiber stuff. You can use sheep's wool or cellulose fiber, which is essentially processed newspaper with a fire retardant in it. So it really does improve the ability of a house to stay cool in heat waves and warm in winter, of course, and homeowners can often install it. The downsides are that it does make a very nice cozy home for rats and mice and other types of vermin. The rock wool is pretty nasty to install. And a very important thing about energy efficiency is to create an airtight seal, essentially, between the inside of the house and the outside, because the more airtight it is, the less heat you're wasting when the wind blows. And that's very difficult to do, or quite difficult to do in lofts, especially in a chalet bungalow like the one that we have. So an alternative is to think of changing the roof from cold to warm. This costs a bit more, and you can see in the photo we're using wood fiber insulation, which is going in between the rafters. Wood fiber is a natural material like cork, which has quite a lot of embodied energy. So that means that essentially you're locking in carbon and preventing it being emitted as carbon emissions by using wood fiber, as opposed to an oil product, which is rather greater in terms of its carbon emissions. Again, you need an airtight layer across the whole roof that has to join onto the plastered walls, and that still is difficult to do properly. It's not typically a job for a homeowner because the airtightness layer is too tricky. And also it's quite hard work cutting up all these chunks of wood fiber if that's what you're using. Needs a circular saw, and I would suggest it's a job for a professional. Also, you're limited by the depth of the rafters, so you can only really fit about 100 millimeters in here, and therefore that limits the amount of insulation and energy saving that you can do by this method. If you go thicker, of course, that reduces the size of any rungs in the roof that you might have or wish to have. So the alternative, the last alternative, is to go the whole hog and essentially take the roof off, take off the slates, the battens that are holding the slates on, and start from scratch and build up a layer of insulation on top of the rafters. So this allows you to get large amounts of insulation into the house. And you can see in this example, we've got the wood fiber between the rafters, then the wooden board is the OSB board is at the airtightness layer, and on top of that are two further layers of wood fiber insulation. So if you put as much as 300 millimeters of insulation in, as we're doing, your house starts heading towards the Passive House standard and supreme levels of comfort and energy efficiency. However, this isn't cheap, it needs scaffolding. Again, you need a builder to do it who knows what they're doing. So, you know, you pays your money and takes your choice essentially. But if the roof tiles are shot or the felt between the tiles is done and the roof's leaking, then it really would be a good time to do this type of major intervention. So you can see in doing this, what we found when we did take the roof off. So we found missing lagging on the pipes. We found some inadequate insulation on some of the internal walls, missing cavity wall insulation, airtight barriers that weren't airtight, and a lot of these semi-external walls in the rooms in the roof that were not properly insulated. You can also see down between the rafters, between the joists, where these wind tunnels are that I was talking of that allowed air to howl around the whole building. So I'm afraid chalet bungalows generally are a poor design, and they're quite tricky to insulate well. Here you can see some of the insulation going on, there, that's the OSB board I mentioned forming the airtight barrier, or at least supposed to be forming the airtight barrier. More about that in a minute, sitting on top of that. And then the two further layers of wood fibre to give us the 300 millimeters in total. Okay, so those are the first measures that I'd like to cover. So I'm happy to pause here and take any questions, and I will stop sharing my screen in a moment.
Okay. Well, thank you, Nick. You kept exceptionally well to time. It's a very interesting presentation, very technical, but I'm fascinated. I'm even more fascinated as an accountant about what other grants might be available for the roof insulation and other elements of the retrofit. Are there any?
So at the moment, for homeowners, there are no other grants. There was a thing called the Green Homes Grant, which offered either £5,000 or sometimes £10,000, I think, if you're on benefits. That was an extremely hard grant to get. The scheme was very badly designed, and a lot of people who applied failed to get it. So and the Green Homes Grant is also offset if you're also doing the heat pump and getting the renewable heat incentive. So that scheme has now died, the Green Homes Grant, and renewable heat incentive is the only one that's available currently. Potentially, the government will bring more in because there's still another 26 million houses out there that are keenly in need of retrofit.
I'm waiting for COP26 because I reckon that's one of the announcements they may make. We have two questions already. Louise has got a hand up.
Oh, hi there. I just wanted to know whether you could offer any advice on finding people who are, well, organisations, suppliers who are able to actually do these retrofits and kind of understand what it is that you want to achieve, and if you believe are going to be able to do the work to the standard that's needed for you to actually achieve what you want from it.
Okay, that's a good question, and I'm going to cover that in my second part. So if you wouldn't mind, Louise, I won't answer it.
That's fine.
Yet,
fine,
but
yeah.
Do come back if you've got further questions after the second part.
Thank you.
Thank you. Donna has a question. I'm not sure if you want to ask it, or shall I ask it? Donna's asking how much the roof project cost.
So I've not got a costing for the roof part alone. It's quite a big roof. It's about 150 square meters. So the whole thing, including taking all the tiles off, doing all the works and putting new tiles back on, is probably about 50,000. It's a house with a very big roof, and that's a huge amount of money. For someone, say, in a terraced house, it would be a lot less.
Thank you. John has his hand up, and then Alex, I think,
Yeah,
had his
have
hand
to
up.
unmute, John.
Oh, thank you. Yes, that was all fascinating stuff. Thanks, Nick. Just one rather brief point about the RHI. I hadn't appreciated that it had changed it into this business of a grant available the way you described. Would it? Do you know if having a hybrid system, you know, with a heat pump but maintaining a gas boiler, would disqualify you from the RHI?
No, I don't think it would. When the amount of grant is calculated, that's done from the EPC statement that I mentioned, and the installer who comes to quote will tell you how much grant they're able to get for you. So you'd know before you'd had to make the final decision how much you're going to be able to get. But a lot of houses that maybe aren't hugely insulated could still benefit with a heat pump and use a hybrid system in the periods of you know, greater demand. Yeah. So it's a good way of covering your heat demand for, say, 75% of the time, and only having your gas boiler or oil boiler or whatever kick in the cold bits.
Exactly, that's what I had in mind. By the way, just one quick point too about your you mentioned this sort of 5-to-1 ratio, which is so frustrating. You know, if you simply think in terms of the cost of energy via gas compared to electricity, because what's missing from that little comparison is the fact that the heat pump has this nominal 2.5 or 3-to-1 benefit. Yeah. So of course that softens, you know, so the effective ratio isn't 5-to-1, is it? It's more like sort of what, 2-to-1 or something like that. And as illustrated by your figures, which show that even before you've done your improvements, the heat pumps seem to be doing quite a good job of keeping your costs at a manageable level.
Yeah, so we could have done it better. The thing that kills the efficiency ratio of the heat pump is trying to heat your hot water, because that's got to get up to about 50 or 55 degrees. And indeed, to kill off all the Legionnaire bugs, it's got to get up to 60 degrees. And that's where the heat pump efficiency falls, where it's trying to go very high. So if you got a hot tap in your kitchen, for example, so if you, and electric showers, I know you're just getting 1 kilowatt out for each kilowatt you put in, but you're avoiding all the wasted heat in the circulation pipes between the pump and the cylinder, and between the cylinder and the taps. The distance between the cylinder and your tap is known as the dead leg. And that's because every time you want to get a cup of hot water out, you have to fill the whole of the length of the pipe with hot water to get your cup of hot out. And then that goes and cools again. So,
and all this is worse still if you've got a combi boiler, of course, which are really, as an engineer, I just think of ghastly devices.
Can I suggest that we've got time for a couple more questions, and I think Nikki in the chat is asking seems to be a related question, not that I would know. Do heat pumps work to heat radiators, Nick?
Oh yes. So the ideal temperature for the water coming out of a heat pump is about 35 degrees. Normally people with non-heat pump central heating are running their radiators at about 60 or 70 degrees. So your choices are either to insulate the house better first, or to have bigger radiators. Or if you have underfloor heating, that's quite happy at 35 degrees. So it can work with radiators, but they have to be the right size for the amount of heat you're trying to get out. I do have a calculation spreadsheet which allows these things to be worked out. It's a bit technical. I'd be happy to try piloting it on someone if they need it.
So Nick, if you're interested, maybe you could drop a note in the chat to Nick.
Yeah, okay, thank you.
Alex, you had your hand up, I think. Would you like to ask a question?
Yeah, Nick, you've had a heat pump installed, a heat to water heat pump. What do you use that heat pump for?
So it's used for the hot water and central heating radiators and underfloor heating.
Yes, and you can use it, I'm assuming that you can use that heat pump because of the efficiency of the whole of your house with regard to retaining heat. But in a normal house, in a normal conventional semi-detached or detached house, that may not be possible. Is that correct?
So it's necessary to do the calculations and work out what is the heat loss of the house with, you know, the windows, the walls, and insulation that you've got, and then it's possible to calculate how big a heat pump would you need, and is that financially doable given that this ratio of electricity to gas prices that I was talking about. So for some people, you're correct, it won't work because they need more additional insulation before the balance gets right, if you see what I mean.
Okay, so following on from that, for those people who have, say, a gas boiler, would it be an efficient way of reducing the amount of gas by having a combination of a heat pump and a gas boiler?
I would say, and some insulation.
And some insulation. And
yeah.
Sorry, just will you cover later on the possibility of using PV panels and, say, an electric boiler? And also, have you had any experience of the possibility of using hydrogen in a gas boiler?
Okay, so let me deal with a couple of those bits. I don't know about electric boilers. I'd be rather worried about an electric boiler replacing a gas boiler because the price of electricity is 5 times that of gas. Yeah. So it could get very expensive, and so I tend not to recommend it. In terms of solar PV panels, yes, absolutely, they're great things. We have some and we're putting some more on, and they do help offset the bill from your heat pump if you've got a heat pump, or any other electricity bill. So yes, they're wonderful. And the third bit of your question, can you remind me?
Yes, it was about the government's talked about using piping hydrogen down the gas supply line in place of methane.
Okay, so the expert I follow in this regard is an Oxford academic called Jan Rosenoff, and his view is that there is a place for hydrogen as a heat source, but probably not in general or as an energy source, but probably not in housing. So he thinks it's more applicable to heavy trucks, maybe some trains in some locations where you can't have electric rails and so on. But the energy consumption of producing the hydrogen in the first place is quite high. I think it requires, you get about 67% of the energy out that you put in if you're using green hydrogen, which is hydrogen generated by using solar power or wind power to split water into its constituent parts, hydrogen and oxygen. But if you're using blue hydrogen, which is made from fossil fuels, you're actually consuming, as I understand it, and I hope I got my figures right, you're consuming more energy than you get out, full stop. And it's not clear whether we're going to be having green hydrogen or blue hydrogen coming through the pipes towards us. So,
thank you, Nick, for some great answers. I think I am tempted to overrun on the Q&A, because we've got another couple of questions which are, I think, related to what you've been previously talking about. Josephine says, if you need larger radiators for heat pumps, can you install it sustainably without replacing existing radiators?
So if your previous radiators were correctly sized and you put a heat pump in and you're running the radiators at a lower temperature, you would have to replace them or insulate. So I'd say insulate at the same time, insulate the floors if you can, especially if you've got solid floors, insulate the loft, and certainly cavity wall insulation is really worth doing.
Right, and just a little help to Victoria, who is looking to replace a roll boiler, and the heat pump sounds a good idea. How would she work out the financial? Do you have a method of doing that?
So I'll talk in the second part about the role of a retrofit coordinator in working out what your package of measures need to be.
Okay, which I think is the moment to move on to the second part of your presentation, if that's
okay. Then thank you very much. Okay, so I will share screen again.
Don't forget to tick the sound box, Nick.
Okay, I'm ticked, thank you. And I'm in the wrong place. I think I've got 2 copies of this open, so let's go down to where we were. Oh no, we haven't been there yet. Okay, we're here. Right, so, okay, part 2. So I'm going to talk in this part about airtightness, triple glazing, and external wall insulation. So airtightness first. And airtightness is actually one of the most simple things that you can do. Drafts lose a huge amount of the heat from your home, and currently building regulations don't require even new houses to be airtight. It really helps to use the materials that the professionals use. That's the ones who specialize in highly airtight houses. My garage is actually part of the house and was a big source of drafts. And in picture 1, you can see that we've used 3 materials to seal the gaps between the garage door and the wall. So first of all, the dirty marks, the black on the brickwork, that's not actually a dirty mark, that's an airtightness paint called Aerosana Viscon, and it's made by Proclimer. You put it on blue and it dries to a black color, and that makes the surface of the bricks airtight. Then we tape this white, where's my mouse gone? We tape this white membrane air tightness membrane over the 90-degree angle between the edge of the door frame and the wall. So that membrane is called Intello Plus, and it's useful for making airtight things that are at awkward angles, basically. And then we use the blue tape called Varna airtight tape from Tescon to stick the membrane both to the wall and to the door frame. Now you may think, gosh, that looks very ugly. I don't want my garage door to look like that, but we're going to be putting insulation onto the brickwork that will cover all of that up. But at least it gives you an idea of the sorts of materials that have been used. In pictures 2 and 4, we've used some air tightness foam to seal gaps around the windows and around the waste pipes leaving the house. So every little crack, if you seal it up, will improve your air tightness. And picture 3, you can see more of the Intello membrane down here, being used to create an airtight layer that linked the new window going in. This is inside the house, looking at where the window board should be inside, but we've taken the window board out. So it links the edge of the window with the plastered wall on the inside. So that's all part of creating the continuous airtight barrier that totally encloses the whole house to eliminate draft. So what we wanted to know was, how well are we doing? And so we commissioned a chap called Paul Jennings, who is the country's leading expert on airtightness, to do an airtightness test for us. And he brought his equipment along, and we opened the kitchen window, and he's put his fan equipment in that window and then sealed it around to make the fan airtight. So the idea is to pressurize the house so the pressure between the inside and the outside is 50 pascals. That's about the sort of pressure you get if there's a steady 20-mile-an-hour wind outside. And in the picture on the right, you can see his measuring device has reached 42.5 pascals difference. It's actually negative. That means that he's sucking the air out of the house rather than blowing it into the house. But no matter, it doesn't make much odds which way you're going, so long as you're creating the pressure difference. On this next slide, you can see the effect of airtightness or a lack of airtightness on your heating requirements. So the current building regulations say that a house is adequate if it achieves an airtightness of 10 cubic meters per hour per square meter, or that's the same as the 4 air changes an hour point, which I've shown in red. When we did our air test, the result we got was 3.5 air changes an hour, which might seem adequate, but we were actually trying to get it down to 1. So that was quite a big disappointment. And after the test was done, we discovered some huge holes where the cavity wall was connecting directly with the outside air. And so we've had to do quite a lot more work to make the house airtight. And I've got a little video here, and you can see with some interesting results that were achieved during the test. So listen carefully. So the first one is looking at the effect of the air test on the garage wall. So these blocks we were treating as being airtight, and this is what we got. Where's my mouse gone? Yeah, that's definitely sucking in air, isn't it?
Yep.
harder to tell on the photo, but
Yeah. Okay, thank you.
okay.
So that proves that those blocks are nowhere near airtight. And our whole strategy of having the internal layer of the wall as the airtightness layer had to be rethought. We also were using this OSB board in the roof on top of the rafters as another part of the airtightness layer. And I think you can guess what result is coming. So how much is it moving in and out, Paul?
Close to 20 mil there.
Yeah.
There wasn't that much downstairs.
No.
Is it worse up here? I think it's worse. It's worse there, you see. That might be coming.
Downwards.
You got enough, or do you need?
Nick, can I just ask, we'll just keep track of time because we're due to start the Q&A at 8:30, but we want to get on to part 3 and the practical tips because I think a lot of people on the call are not as technical as some. Would that
let me crack on through then. So sorry, I don't want that. How do I go to the next slide? There we are. So we made the house more airtight with various measures. Let's skip forward. Let me briefly talk about mechanical ventilation, which I mentioned earlier. So this is warming the new air coming in with the stale but warm air going out. And that saves about 10% of your total energy bill. So we installed a network of piping around the whole house. And it's easier to do, of course, if you've taken the roof off. It can be quite tricky otherwise. You can see that I co-opted child labour to assist with the process. That was quite effective. The joints on the pipe work have to be made airtight. They've already got some rubber gaskets on, but we further taped them to make sure they were completely airtight. Should I cover triple glazing or skip it?
Maybe skip it. I think that would be helpful. Yeah. The people will have the slides afterwards, so they can go through it. Yeah.
Okay. So some practical tips then. Critical, of course, is to exclude drafts, and you've seen that about airtightness. If you are excluding drafts, of course, you need to make sure there is adequate ventilation. That can be done with trickle vents in windows or by fans in certain rooms if you need it. But we need to get rid of the old carbon dioxide in the house. More loft insulation, of course. It's always worth not overfilling your kettle. Just use the water you need, and that will save quite a few kilowatt hours from your energy bill. Some energy suppliers have a cheap night rate for electricity, and you can sometimes delay the time at which, say, your dishwasher starts or your washing machine starts, so it runs in the night rate period. We're switching to Octopus Energy at the moment, and their daytime rate is 16p and the night rate is 5p. So we'll be able to save a fair bit. You might also think these days that 16p is a pretty good rate anyway. So if you do use a fair bit of electricity, have a look at Octopus Energy, because they're perhaps one of the more stable electricity suppliers and their rates aren't bad. If you have an electric car, anyone out there, the 5p night rate, of course, is great for electric cars. Energy monitors are always useful. We had a smart meter fitted a bit ago, and it comes with this thing that you can sit at and stare at in your kitchen if you don't want to watch television, and it will tell you how much energy you're using. So that 3.99 kilowatts was just two devices that we had on at the same time. I think it was the grill and the hob was on at the same time. You may find it's cheaper to not use the grill for your toast, but get an electric toaster. That could make quite a difference to your bills. Thermal imaging cameras are useful. You can get ones that tack on to your mobile phone. I think this one cost probably about 200 quid. And you need to take an image of, say, a wall when the temperature difference between the inside and the outside exceeds 10 degrees. The yellow at the bottom is all the heat loss that's leaking out between the floor and the wall. And the other yellow patches on the wall are where it shows you where the cavity wall insulation isn't adequate and isn't doing its job. So you can use it to find areas where you're leaking heat and plug those with your draft excluder. Cavity wall insulation is good stuff. If you haven't got it, and you've got cavity walls, it may be worth doing. I'd suggest use the polystyrene beads rather than any other material, because they don't transmit damp through the wall. And if there is any moisture gets into the wall, it can dribble down between the beads. So I think that's now the recommended type of material to use. And of course, I was talking earlier about dead legs on water pipes. If you insulate all your cylinder to tap hot water pipes, you can reduce some of the wastage. And that's a pretty cheap measure. Some other practical tips. If you're thinking about retrofits, the first step is to decide what your overall objective is. So are you trying to save the planet and reduce carbon emissions, or are you simply trying to reduce your energy bill by a certain amount? Because depending on which objectives you have, that will considerably alter the extent to which you would wish to or would need to do energy saving measures. The design of the house retrofit you do is critical, and it does need an eco-qualified designer to do it. So if you're thinking about single measures or a fairly limited intervention, then it's really worth talking to outfits like Warmer Sussex or Brighton and Hove Energy Services Cooperative, BESCO. Warmer Sussex have a nice website that allows you to put information in, and it will calculate what you might save and what the top measures are for you. So that's a very good place to start looking. If you're a DIY enthusiast and you have DIY ambitions for retrofit, then I'd highly recommend looking at the website of the AECB, the Association for Environment Conscious Building. They've got some fantastic courses that teach you all about how to do retrofit, and also why doing some things wrong, like there are some types of internal wall insulation that can be rather tricky and can cause more problems than they solve. So AECB is a great place to look. Or if you want to go the whole hog and get to the passive house standard I mentioned and have a really highly efficient house, then you could look on the website of the Passive House Trust, which will list designers that you can contact. Jim Miller Design is one in Brighton, and he's the chap we used. Horton Mead Sustainable Design, also in Brighton, would be another good place to look. So if you have the time, you can teach yourself with the AACB courses, and then you can write your own plan. And if you've got absolutely loads of time, you could even do the Passive House Designer training and really become an expert in all of this. You may very well need planning permission. We did, and that was just to change the colour of the walls, which were going from brick to a white render. So that will be the third step if you're following this route. And you may well need a builder or tradespeople who have deep experience of retrofit. And my top tip would be use the wisdom and expertise of your designer to help you find a suitable builder, because probably 90 to 95% of the builders out there don't really know how to do retrofit. So I'm sure that will change, but at the moment, it's a fairly new field, and you need to pick the right ones. Some useful links for retrofit design. These are links to the organizations that I mentioned. And in terms of suppliers and materials, Green Building Store are pretty good. They do triple glazed windows, ventilation systems, all sorts of insulation. The builder that we've used is DP Johnston, and I would thoroughly recommend him. I think he's more interested in the larger and more complex works. Mike Y is another company that provides all sorts of specialist materials, and a good source. So there we are, covered the main parts of the talk, so I'm happy to take any further questions.
We have time for a couple of questions, and there are two in the chat. One from Louise. Do you want to ask your question directly, Louise, or will I? Okay, you're there.
Yeah, sure. I just was wondering whether the mechanical ventilation heat recovery system prevents condensation building up in the house once it's airtight.
Almost certainly yes, because it's giving you sustained airflow of at least one air change every 3 hours, and it's designed actually to provide sufficient ventilation and keep the house condensation free. So it really is a good measure to do, but it is a bit complex to install.
And Linda's asked a question. I don't know if you want to ask your question, Linda, or shall I ask it for you? If you'd like to ask it, then do unmute your.
Can't see.
Yeah.
Yeah.
Go ahead, Linda.
Hi, Nick.
Hi, Linda.
Yeah, it's a very simple question, maybe a bit naive, but I've asked, if you have an airtight house, does that mean you never ever open any windows, even in the summer?
It's not a naive question. It's quite a good question, actually. No, it doesn't. If you have an airtight house, then you will need a ventilation system of some sort. You'll know the saying, no taxation without representation, and I'm sure that's close to your heart. So the other one is no insulation without ventilation. So if you make your house well insulated and airtight in the process, you have to make sure there's sufficient ventilation as well while you're doing that. Otherwise you get off-gassing from artificial fabrics, cooking smells, etc., all building up. So no, open the windows, get the fresh air in and get the COVIDs out.
Patricia, you've unmuted. Have you got a question?
Yes, yes. Can you hear me? Yes.
Yeah.
Yes.
Mine was, if you're living in a house where cavity wall insulation was put in, let's say 30 years ago, one of your photographs showed patches that where the wall wasn't, the insulation wasn't working efficiently. Can that be replaced or upgraded, you know, or are you just left with what was put in?
Okay. Yes, it can. There are firms that specialize in taking it out. One firm to start with might be Cavity Wall Ties, who I think are in Brighton. But anyway, look up the name Cavity Wall Ties. I know it's not cavity wall insulation, but that company will give you an assessment, I think, of your cavity wall insulation. And there are others. Some of these guys are cowboys. I think the Cavity Wall Ties people are good.
Yeah.
It costs maybe £1,000 to take it out, and then you of course got to pay for putting something else back in. You would have to watch out for cement lumps that are bridging your cavity. Cavity Wall Ties could do an inspection for you, because if you've got that bridge across the cavity, you could be getting damp across. So if you've got damp patches in the house, you might need an inspection, and they could do that for you.
And presumably, if you're getting your, oh dear, what was the, I've forgotten the term now, the EPC certificate, would that show up whether, if the cavity wall insulation was efficient?
No, that's EPCs are just a tick in the box, really. So they say, have you got cavity wall insulation? Yes, you have. Tick. It must be energy efficient, or, you know, a degree of. It doesn't tell you about quality.
Okay, thank you.
Okay, great, Nick. I think we've come to the end of the allotted time. Just to say that the slides will be available, and we put them in a newsletter to people probably next week, and the recording will be on our Facebook page eventually. And the links that you sent me, I haven't put them in the chat because that can sometimes confuse those of us who are looking for questions. So what we're going to do is create a document for all the links that were put in chats from all the events. So I will put all those links in there as well. Is that okay? Yeah.
Okay, very good.
Yeah, thanks, Nick. I mean, for some people, it may have been a bit technical. For some people, this may never apply, what you've heard, but I think it gives a great indication about what's possible if you have the time, the money, the inclination, and all of the above. I think personally, I was very inspired by what you've done, Nick. So thank you very much for doing that.
Yeah.
I'm now going to stop recording, I think.